So the question is the servo. Part of me want to tell the people, you know, I want a new one. Well, there are actually screws here. And part of me wanted to open it, and I thought it was glued. But I just realized, actually, it's not glued. It's screwed together. So how could we not open this? How? So we're going to fix the program for the robot zone. But let's just quickly look inside this. So this is a tiny screwdriver. So we have it on film, right? Have you seen such a tiny thin screw? It's like a needle. So it would be cool if we could fix this. So don't throw away because there's stuff in here. I've never seen such long and thin screws. These are unique. You see how long they are? So that's all of them. So it was not glued at all. You can see all of it. And what could possibly be the problem here? Sometimes it's not. Now I can move it a bit. Maybe it is something with the. Let's see. Yeah, I can lift these up. And that one too. You see how it is connected? Let's film it like this. And this one through here. All these two. There. And then on the other side like this. So we have this documented here. And I can't move it. I can't rotate this. Let's see if we can do it with both hands like this. Yeah. What is the problem? I can see some piece of metal here, right? We need to zoom. This is not enough. No other way. I'm a bit gooey, so I'm trying to be careful here with it now. So something like this, then I can lift it to focus. No, you can see the goo there on the table. Okay, so this is loose too, and it can rotate separately. But this is stuck to it. So this looks okay. This one looks okay. And I'm gooey from this, so I'm kind of silicone goo, I think. And then we have the tiny thing, those in between. It looks a bit dirty, but not like broken. First I thought it was broken, but I think it's just... So, getting rid of some of this fat, so we can see better. So the gears looks okay, and it's just these two. And this one looked okay too, doesn't it? Or does it? That's my food downstairs. My tummy said growl here. So that one and this one is supposed to go like this, so let's keep them this way. And there we can see it has a flat bit here that goes into the other bit here. And there I saw plastic, right? So let's look at this here. This is what we see when we look at it from the top. The metal, we're thinking, oh, it's good quality metal, and then underneath where we can't see is plastic. So this is light. This weighs nothing. So let's, these were all loose, so let's just, I'm thinking I'll pull up the pin there too. And it was symmetrical. So very much gooey stuff. Nothing obviously broken, is it? Let's actually, I'm looking at a tiny image of this. I could preview it, and why didn't I? So now I will see it big. So, is it broken here or not? Or is it just gooey? I think some of them are not full length. Like here. So I can hardly touch it with my nail even. Let's get some thin stick thingy to touch stuff with, because my fingers are too big. So let's see, this is kind of big too in this circumstances, right? So there it is. So this looks huge. It's not. Should I take an actual needle maybe? So this one is huge too, right? Maybe it's sharper. So compared to this, let's see if I can just touch these. So that's my tiny pinky. Yeah, maybe looking at this direction is the best. So it's so gooey. So let's see here. Yeah, it looks like they're not as high all the way. You see what I mean? let's look at the other side then. This is just transferring the power up here, and it starts with plastic. So this is the metal geared version. Is it? This MG starts with metal gears. It doesn't look very turbo, and MG need a micro servo. And then we have all the power coming from this. This is where the power comes from. And then if it's this one actually moves. I see no problems here. But of course, if this is moved the slightest bit, it won't move it. So let's see if it's this side. Well, I don't think the problem is in this thing. I think it's something in the cogs or how they were like placed. But it worked sometimes. It's this oddness, you know. Oh, I hate silicone going on the fingers. Yeah, so let's see if I can like move this here. This looks like it's like plastic pieces, right? So the other hole is over here. And this is just a hole for positioning the straight, I'm assuming. So I didn't know it was two parts in this clear way. So I guess this is the next opening. So if we were to push these in, we get into the other bit of it. So in here is a tiny motor. I can see the metal of it there. Right? So, and on this side it's a plastic hole and two parts on the sides there. And then on the bottom there's a board. And I'm assuming it's not very advanced electronics in a servo, right? By the way, let's see. Yeah, so I can spin this any number of times in both directions. That's not how a servo is supposed to work, right? So let's connect it. The robot is still on. I'll just switch what is connected here. So let's actually power off for a second here, and let's pull out this one. My God, is it so hard to get out? Yeah, it's because they are strapped together now, you know. So it's tight. So let's now plug in this one. since we have our commands from stream to test this servo, and we turn it on, and kinda as suspected, this servo is going crazy. Can you see how it spins? It never stops. It's just spinning like crazy. The servo was turned into a motor. So it's spinning. And these other parts here, what would have happened? This is odd. So let's click the reset button. It stopped for a second there. The cables are connected the correct direction and everything. So as a servo, it's just supposed to run a bit, and the cogs are not changing this, you know? Alright, it's over there, it doesn't help. Yeah, so let's turn power off again. So it seems to be working fine as a motor. So let's see if we can, this side here, if we push these in on both sides, we can get further into it. So put this one here, and that one there. Let's just first see where on earth the opening would happen. So let's zoom out a bit there, because it's too here. So this is what it looks like. Yeah, there's another level here. So I'm assuming this would be where it's opening, meaning also the labels will keep it together here. So let's just open the lower bit of them. So here we can see, I think it actually opened a tiny bit when I did it, maybe not. It was always like that. So, checking how servo works, right? Let's see if we can fix it. This kind of tiny thing. It was funny, yeah, and this was just attached then by the labels and the screws, of course, the screws. So this was actually off. We didn't need to use the other things for that. So now you can see the electronic parts. So there we can see the motor. We're going to open it more. Don't worry. So 502 volts. It says there. So this is where this pin goes in here. Let's see if we can see if it, no, it won't go that far down. So the pin, it's not really that, you know, it's not that tight. So of course this will move a bit, right? It just has these on it. The metal one visible from the outside, and this one, plastic one, that's a bit broken, and the downside where you can't see a thing. And then the plastic bit here. No, this one should probably be in here, right? And this one goes here. Yeah, so this one, will it wiggle now? Yeah, it wiggles. It wiggles a bit. This wiggles a lot. And it has plastic cogs on it. Right? So if we pull this one up, and this is probably how they build it, right? And then we put this one in between. There. So it transfers the power to this one, who is just loose on the rod. This one is attached to the rod going down to the motor. Well, that one is the motor, not that other one. But it still had something there. Maybe that's a limitation. And there's electronics in it, a sensor when it moves. Maybe that's why it is spun forever, because it didn't get I'm at my end phase position. Right? And then we have the other one. The metal stuff that's visible, right? So these top parts are visible from the open, and also this one was loose. Let's see. This one, let's see if I can find the place. This one was loose, and it just goes in here. So let's see if we can fiddle it about. So now I can't rotate this. It goes kaboofy. And this looks outside. This one has a tiny hole there with the like pushing it down. This thing there. So it's supposed to go here. There. So now it's back together again. And let's see if we can rotate this. We can't. So now when it's attached again, let's put the bottom back on, since it's just a tape in the way, I guess. So then I also don't touch the electronics and short something when it started. So it's all back together again, the same way it was before. And will this make it not spin forever? Will it spin? Will it move? It will be connected to stream, meaning you can control it if it works. Yes, and now there was a sensor saying I have moved to my position. So the only problem I can see with this then is that the pin holding the plastic gears here is wiggly, and the gears were a bit like shorter on the corner. I don't think that would matter, right? So let's give it a command here. So let's do R50, right? And I'm just getting something to make it more visible, the movement. Because they are tiny cogs, right? So here. So what will happen? when I click chat here on my R50. Yeah, we can hear how it's not like all there. So now when I know what it is, and let's click the reset button, making it reset. So now when we know what in it makes the things work a tiny bit better, we can actually look at it like this too, of course. The only thing we need to make sure is that this pin here doesn't fall out. So I'll just so let's just hold it like this so that it can rotate freely, right? So there. We'll see what happens. So how will the gears in this work? The problem now is that I have to type. So exclamation mark R space 90 going 90 degrees. It worked. So what didn't look perfect in this? I'm kind of thinking the part of this gear, where's this pointy ones? Here, part of this one, it's just a tiny bit on the top. Could that do anything? I don't think so, right? And this is on the bottom, so even if this would move, it would be the metal ones that moved. Like out and in a bit here, right? The bottom where the plastic is wouldn't move as much. Annoying. So if we click the reset button, it will do the same thing but quickly. So let's get this one on film too. So I'm clicking the reset button. It just doo-doo. And I'm thinking let's do the command once more. Or let's do 200, meaning all the way to one side. I could change the speed, but then I have to connect the Arduino and the robot to the machine and change the program there. And that's where I set the speed of this. So I feel a few like, should I just wash it? Is it just the gooey stuff and we see the dirt there? I can't really see the problem here. It's definitely not the motor itself. It must be the cogs. It might be the motor, but it seems to work, right? So I'm resetting again. That worked fine. So assuming there's weight on this, you know, and it's not supposed to be able to rotate when it's powered, because it will always try and get into this position all the time. So if it was moved a bit, it will try and get back to the position. Right? And what will happen if it's, yeah, so here I can feel it's, oh, so there is, now we saw it. That's what happens. That's what happens all the time in these. When it's trying, now it can't even do it. Yeah, so it is actually this. I can see the distance between them here. This one is not pushed in enough, and then it goes crazy. Since it's the position of this, when we pull it out, we will see that it is a flat side, and that's what makes it sensor that it feels some kind of sensor there, that it's in this right rotation. And otherwise, if it's not, it just goes forever. Yeah, so I'll have to turn it off. So, is this a problem? Should we just put a bit of stuff on the side of this hole here to make it more to the right side? Change a bit on how it's, when we put it together, we really push it to one side. That feels like a stupid thing, right? Put a tiny bit of glue on that side of this tiny hole and make it a bit bigger on this side. Yeah, so we saw it do what it does when it doesn't work. And if we put it back together, so let's just push that thing in. Let's just put these in here and pull down the little pin here. So also this is what it could have looked like, right? So now it is in the hole there, but it's very loose. So this was when it stopped working. So we can almost see the tear of the metal ones there, right? How they have been, they didn't break from it, but they were just spinning. It was just spinning like this. That's what happened just now. So if I do this again and hold it, trying to just do it with one hand, is it possible? Power on. So if this was slightly rotated, this bit here, from what it's supposed to be, for example, that it's hard to turn, that it can't do it, that it can't turn it because it's too heavy, then what happens is that it's not positioned in the right. Let's just turn off power, and when power is off, yeah, so here we can see that it's, I can't really rotate this as the others. The others, when they're still, they can be rotated. So I can't rotate this one, except for it's doing the clicking when it's, these are not connected good enough. So maybe it's inside anyway in the motor, because the others can move. I'm thinking I want to move another one too. So this is the flat sides there. So if we just remove this bit and this bit, and let's just keep this bit in here. So there's no connection to how that works. I mean how it's, the motor is running to how this is. And I can just rotate this one now freely without this being affected. And we turn it on, it will go crazy until I turn this to the right position. Can I even stop it in the right place? So here is the right position for it to be stopped. So we can see that thing there. Okay, this is cool. So it's like, if I rotate this, which probably is a potentiometer, right? It's just, we set the speed of this and the direction. Roll. Other direction. So let's see. So it's slowly going now. I can hear it. So yeah, right, we have those two plastic bits here. So I don't think there was any stop on this. So if I turn it like, let's put this back on. So you can see how little I turn it when it's increasing speed slightly. So if we turn it a lot, there it's where it clicks. Direction. Up. So it's really the so you can hear the directions. Interesting. So let's actually turn power off when we make this. I could remove that one too. So these special screws, I don't want to lose them, so let's put them in the same place here. So it's opened, and this is obviously not connected there. So we have these two things to click this bit loose. Oh, and I can now move this. Can you see? I can move it. That's the way it's supposed to be. So it's not these that this is not what's stuck. I have to look back at the video later. Can you hear that? I'm gonna just angle it. Right, I could have used a screwdriver. Yeah, maybe it just was this sound. I was like, what is it? Yeah, let's not a flat screwdriver. Let's just put that one off because it's in the way. So no, you know, I don't want to bend stuff in here. Right, so So we can see these 3 legs here going into here. I thought these were like more advanced, probably. No. So motor. Yeah, I would like to see the other side. I can see a ship there. So the motor, the ship, so let's just read what we can. 662K. These are just the 3 legs. Yes, I wish I knew what everything was. But and I'm thinking, how can I get more into this thing? Let's just slightly bend here on the side, if I even can get anything in here. So I'm not going to break it. I will just see if I can. This is not even thick enough to fit in there. No, I mean, it's too thick. Everything is too thick. So of course a board. We don't want to use a board as like leverage to get it out, because that wouldn't work, right? So yeah, I guess the motor might just be stuck in here because of this. Yes, so let's try again with this and actually try and push it out. Right, I didn't do a serious try. Not serious enough. So I can definitely move them. What if I have some pressure on there? Yeah, it's definitely moving. You can see it's a bit further out, right? So is this motor like glued here? No. So these stopped me from pushing it further that way. So here it is. So guess what? I want to measure these. No. And here we can see so we have this in here, rotating it for us. Let's just see if we can push it down a bit so it's it's more stuck. We can see here, we can rotate it. And it's kind of like not very like, well, I even pulled this off. Yeah, so it could be like a wide range of places here. It's not like centered and stuck in the middle. And if we were to start this now, we will have the same thing here. So until we put this in a special position. I'm just holding the cable so I won't short anything. If I go to the other side here, so now I want to measure these legs to see what they say. So is it slightly moving now? It feels like it's slightly moving, yeah. So there. The cutest, tiniest motor here. My pinky. Or compared to the screwdriver, the tiny screwdriver, that's like nothing. It's not big. No, it's running again. Yeah, so I didn't put this one on straight, so that's why it's not straight now. So let's measure a few things. Let's see if we can put this like in this. Maybe it will stand. And it's just a cable rotation breaking the thing for me here. And put that on there. So now we have it standing on the desk. So the problem now is that over here is where I don't want to move it again. Can we see the numbers from this? Nah. That's okay. So we have 3.3 between the outer ones, and I'm kind of assuming that it will stay this way. I have the clampy thingies. Where are they? I think I probably borrowed them. I'll just go over to his room. Oh well. I'll just look through my drawers too. No, not today. This will have to do. This will have to do. So let's see if I rotate this slightly this way, and I touch these two there. So we will hopefully get the measurement, and now it is spinning, and we can see that the value doesn't change when I rotate this, which is what I wanted to see. Good. So let's just get this one straight again, because it's annoying that it's so straight, and put this kind of straight here. Come on. It's not like it's advanced or anything. Oh, whatever. Whatevs. I can't do it. It'll have to be a bit crooked. Okay, so actually I bent the whole thing, right? Yeah, it's not like it's sensitive or anything. It'll survive. The hard thing is to measure the middle leg. There, I have it. So when I by mistake short it to the motor itself, that's when it jumps. So 1.6. That sounds kind of logical, right? Halfway in between the two. And I'm trying to measure this. The microscope isn't doing much good now, is it? Though it's kind of cool to see it, it's just lost where I'm at. So trying to measure here and here. Let's see, that's the other side. That should be 3 always, and then we move to the middle leg and see if I can stay there but be a bit move this. So if I move it one direction, 1.7 there, .8. So if we turn it, the place where it hops direction, 2.4. What is it doing? Yeah, so now it's on 0. So the outside is still the same value, but this one is now almost 0. Meaning a lot of ohms. We should have maybe used this. So let's outside nothing. Middle. So let's put it at the middle place again. This is the hot place. We can see the metal there. So it should be like on the other side here, where it slows down and stops. So let's see if I can move this into here again. So we have this. Oh, it's so quiet. And then I measure the other side. Through here. Again. There. So I don't think I'm doing this right. Let's see. So this should give us a low. It's not a lot, it's just a cable, the resistance of the cable. Yeah, so this isn't working. I can't really see what it says, you know. Yeah, so if we were to pull this one to the side, see, this is where it will hop. You see the metal there, so we'll switch directions. And that's, I'm thinking that this gosh. So what if I hold it like this? Can I reach it better then? Jag kommer snart, gubben! So my kid is calling. And this totally fell away. There. Oh. I'll be right back. Yeah, so I think it's on this. It's about time to actually read something on this, but it's also kind of fun to see how this works, right? So we can see that with this we can adjust the speed, and how it is now is that if it's 0 volts, well, depending on what leg here, of course. Oh gosh, it's warm. Yeah. I want to see the ship too, and I don't want to bend these back and forth. But maybe we can see it with a microscope like this. And then I'm like content with this experimentation for now. Actually, this won't work. Maybe like this. It'll be the wrong direction to read. But the light will have a chance to reach, maybe? So, what if I use my phone as a lighter? My goodness. So, let's just... Okay, I had my camera app open, so I couldn't use the light. Yeah, that's there. That's what I want to see. Come on. Show me those letters. They're almost there. 1911 A, but what's the top line? KC 920. There we have something. Let's actually switch to full microscope screen, and I will come on, light. There, it's all clear. KC9C, right? KC. Well, we can look at the video. So, now this is a preview. Maybe not. What else could have it been? An 8? Ah, whatever. Ah. Yeah, I think I will close the top camera actually for a bit, so it can cool off the phone. And I'm going to go and get some food. So what was the word I was thinking? Here. And here we can see another image too, right? So I couldn't see any ohms when I measured the potentiometer, which is kind of annoying. Let's just click something. So it has 3 ground, signal, and okay. I guess that's a tiny plus that I can't see. Why not just say VCC or something? This is the exact one that we put there instead, I think. So, bigger. There. Yeah, so it's a 555. The ship. So the stuff we saw was like crap, nothing. Which we noticed when we tried to Google it. So a 555. Let's see here. We have the plus. Yeah, forward, reverse. Oh, so that's their thing here or something. No, this is not at all what I'm thinking, what I'm doing. No. I want to see the internal. Yeah, this is not what we want. So, internal. Is it so hard to yeah, what's inside? Do we have to look at a video? I don't think so. Let's see. Here.
Panda Tongue says,
when are you going to create a device to allow chat firing Nerf darts at you for channel points?
Okay, we can do that. It wouldn't be hard. But I'll just put all the kids' Nerf guns back into the shelf here from being with us to the country house. Well, I don't think so. I'd rather have
that would
a
be funny,
water gun,
lol.
right? Oh yeah, if you had to aim to, it would be kind of funny. It would have been perfect aim already then. No, no. A robot to control a Nerf gun. Hmm.
Channel redeem. Make fix-it dodge darts.
Yeah. My god, this is someone who's calling it servo motor is wrong. I mean, people trying to help you and you complain. Oh, let's open that then. Register to view attachments. Oh, that's so annoying. Register. Yeah, so I want to know the internal. Oh my god, they really broke it. It seemed to be glued though. Yeah, so here we can see a chip. Link. Okay, there's a link. Okay. Yeah, this is a similar one. This is similar numbers. This is KC24C2. So if this was 9202, we didn't find anything on it. We got lots of stuff like this. And if we searched for ship, we didn't get anything. But what if we do servo? Yeah, so not a lot. So KC2462. So 2462. And then we find a lot. So I'm thinking that's definitely not a 2 or anything like that. It could possibly be a 0 or a very no. It's very similar to the 9 here. PWM, dim constant current output LED driver. Yeah, I don't think there's much difference. Let's just look at something. Oh my goodness, this is not readable. Is it my dark mode that's breaking them? Yeah. Yeah, so this is definitely not the same kind of thing. So why did I even end up here? I can see that looks wrong. And so back instead. Yeah, so here they're actually selling them. So challenge. How can I understand a servo well enough to build one? Yeah, so since I'm eating, let's... Do I really want to read all this?
I am trying to understand exactly how a servo works, so that I can build one. I bought and built a small robot arm kit, and it has 5-gear DC motors to actuate it. I would like to control the robot arm from a computer, but in order to do that, I need to make the actuators smarter, essentially turning them into servos. I opened up a couple of inexpensive analog RC servos, and the design looks simple. It has a DC motor, a potentiometer on the output shaft, and circuitry to turn the PWM signal to a position for the output shaft. My problem is that after opening a couple of servos, I got a range of controller chip models ranging from KC2462 to KC8801. These all seem to be made by the same Chinese company. Unfortunately, I can't find the data sheets, and even if I did, I do not understand any Chinese dialect. My question can be summed up as this. Is there another servo control chip datasheet that I can read? Is there a website with enough information to learn how exactly a typical analog servo does what it does? Is there perhaps a book with the above information? Please understand that I already understand how I could hack a servo motor together. I can reprogram an 8tiny45 to take some kind of positional input from one pin, an analog input from a potentiometer on the output shaft, and then output direction and speed to the DC motor. Speed accomplished with PWM in this case. Maybe with a huge cap on the supply to ensure the DC motor doesn't cause too big of a voltage drop when it starts moving. However, I don't know if the above would damage the chip with inductive feedback from the motor, or if there's a different way to do the speed control. I would like to understand how the problem is solved in a real-life professionally designed and built servo motor. As for my background, I did some electronics in school, and I've been playing with Arduino and 8tiny45/85 microcontrollers for a few weeks.
Open servo. But I want to know how this works. I don't want to know anything else right now. Another RC servo I see was made by Cygnetics NE544. Okay. Okay, so it's blocking it. Okay. It's just HTTPS thing. Whatever. It's here for 10 years, right? Yes, I've read the code for the Arduino code for servos, so I kind of know how all that bit works. I just want to know how the actual electronics inside it works exactly. So OpenServe is the same one. Okay, so this was an old link, maybe. So servo amplifier, that's what it's called, servo amplifier. So let's just all links today are a mess. Okay, so it's so well so first of all, let's look at something like that, but then we need to, so sometimes it just translates sites that I already know, the language, and sometimes it doesn't do a thing. So why does it sometimes translate stuff? I don't get that. So this is definitely not in. Yeah, so we'll see what it says about this. Yeah, so Chinese detected to English. It's working on it. Homepage about us. Chip. Servo. Do you remember the numbers? So, my god, it's long ago in there. 9, you looked at 9C02. So maybe it's 9102. No, it's not. It's not. 97. That must be 9702. And there's just some of the dirt and stuff. Yeah, so this must be it. So the problem now is that this won't be opened here because I blocked PDFs from being opened in Firefox. Yeah. And it will be warning about HTTP again. So let's see. Yeah, this is much better than nothing. So this tells us a lot, even if it's so we have 3.3 volt here, and this is HVDD, and then I can't read it, of course, but we can copy this, we can put it in translate. Can't this like translate automatically? Let's keep that one up or whatever. The poor thing is a lot of text. Little servo motor controller. It's a dedicated motor driver shape. The circuit integrates an A bridge drive circuit designed with N-channel and P-channel power MOSFETs and a dedicated which is suitable for driving the steering wheel drive of an electric toy car. Okay. The circuit VDD has a wide overheating voltage. A built-in overheat protection circuit. $150. So I'm going to move this to the other screen and let's look at this. So this was that first text, and then we get to the list where it says like designated more adjustable according to customer, mechanical structure, low cost, low resistance, toy motor driver powered 2 to 4 AA batteries, or rechargeable is what it said here. Smart home, just nothing else. Last line. So pin arrangement. Well, actually, let's select text again, because this shows me which lines it couldn't, which are images. So this probably says pin arrangement and pin definition. Pin name, input and output, function description, but input, position feedback input. Yeah, so here we have the interesting bit. So come on, I want to select text here. So motor interface, and then we're down at the next bit. So let's just copy this bit. Let's make since I'm hopping to my Google Docs, I'm for 2 seconds not letting you see all my documents. So we have let's start ShareX. So of course we should put this. No, that's not where I typed that. Come on. Oh gosh. It's so annoying when this thingy won't pop up. I clicked it on the other screen, it wouldn't pop up. Extremely annoying. So let's use also, of course, we shouldn't do this here, right? So we should put this in our notes. And this is definitely hardware, and this is servo motors. And whatever, let's make a note here. And this piece, no, because I copied something else. Let's not do docs. There, and let's now get that image. So, like somewhere like there. And there we have the name. It's KC9702. And I tried this as a 2, but not as a 7. That's a thing to remember. So, right, we could actually have used Google Docs for something else before. We could actually make like a table of this, right? Or we could do it. We can do it here. I think we can do it just as well here, actually. So we can add a table here. So I'm just curious if we can do this and if it's logically readable afterwards. So we want to do a table. I'm sure we can do that here, right? So we need to add another row, or we can add another column. Well, I'm just taking the opportunity to read how it works. Yeah, so now I think we can just like, no? Oh gosh, that's not what I wanted. I wanted a line to be copied. Okay, so it selects like this. Oh well. So how come the first time I copy pasted? Okay, because it actually adds there. So if I paste it here, then it will add it afterwards. 1, 2, 3, 4, 5, 6, 7, 8. So we need another one. So yeah. Alright, we can't ever remove that. So I think using the mouse is... So this is not really needed, you know, but just kind of testing the obsidian tables here. Yeah, so this is an input, and this is position feedback input, which tells us that this will probably be connected in some way to that potentiometer, right? So PWM, yeah, so the first one is just PWM, and then we have input. So let's think here logically. So power supply, power supply, ground, output. So no more inputs. So this is where we get the input signal. So power supply, and we will have 2 power supplies, and this is a 3.3 volt power supply. Okay, so it fits in one line now. That was like what happened. And then we have H, VDD. And here. Ground. So let's actually look at this out A, out B. Yeah, so I was like, what? So out A, out B. This I don't know what it is. Motor interface. Meaning this goes straight to the motor and it will differ depending on stuff. I mean, the voltage will change. Yeah, I want to know more about this. Why doesn't it tab? So, because I'm tabbing there. Okay, now. Good. So this is so much nicer than you know, it even made the headers automatically. If I wouldn't have wanted that, I would have been annoyed though, so would have been a mess here. So yeah, what's the header here? So this should be application circuit. And then it says electrical parameters and going temperatures. So parameter symbol, minimum, typical, maximum, unit. And this is unit. Power supply parameters. Operating voltage must be this. Yeah. Operating current. PVM. Input voltage. So there. VH. So pot input. Yeah, so I'm going a bit, oh my god, this is a lot to read, you know, and I don't, maybe this is not a good thing to do on stream, and we don't have to read about the measurements. So what other text is there in this? Because there is more. It's out, it's finished, and in this one, oh, so it's double. It's doubled. Okay. Sure. So I was thinking, is it a lot more? But it wasn't. So Paul Kelly fell asleep hours ago. Yeah, so who said you couldn't read this, right? You don't have to know Chinese at all. And we have a bit of information here. And the you're nice to Kuwait part here. So now I would like to see the circuit in which it is usually put. Oh my. Maybe I shouldn't stream for like forever. It's almost 7 hours. Right. So this was, we found on ours, so we don't have to look at this one. Though we can just quickly look at what it looks like. My god, I don't want to download something now. Just, it's so dull. It's all. So, here. Yeah, this is more complicated. So we don't want to read about that. And openserver.com, that the old Internet Archive link, yeah, was an open hardware project that aimed so upgrade the server by replacing the controller board. Okay. These board designs are still available on GitHub. So, if it is like, let's just let it open. If it's supposed to replace the chip, it would be kind of similar, right? Maybe not. Well, I'm kind of thinking this, we don't need to read this. Yeah. So it's very warm in here. So I'm thinking of opening the window. Or maybe it's time to actually stop streaming, but I would have liked to fix the program too. And that's not a big thing to do, it's kind of short. So I think it's time for fixing the code for the robot here. And